video of O-level physics, and today we are going to discuss about speed-time graph. We also discuss a little bit about acceleration, which we already discussed in the previous video. We have talked about what acceleration is, what does acceleration mean, how does an object move when it is accelerating. We'll just go through it a bit more, and then we will come to the graph and see how does the acceleration that we have drawn here, the movement of an object, is depicted in a graphical form, and how does the graph show exactly that thing, right? So as we discussed in the previous video, when we say something is accelerating, we mean that how much the velocity of the object is increasing in every 1 second, right? So per second, the increase in velocity is called acceleration. So let us take an example that you're given with an object which is accelerating at a rate of 5 meters per second square, and the acceleration is constant, it's not changing. Throughout the journey, the acceleration is 5 meters per second square. Now, the object starts from point A and its velocity was 0. After 1 second of motion, the velocity became 5 meters per second. Since it's 5 meters per second square, in every 1 second, it will increase by 5. After 2 seconds, it's 10 meters per second. After 3 seconds, it's 15 meters per second. So in every 1 second, the velocity is increasing by 5 meters per second. Now, how do we expect the distance moved by the object? How far did it move in every 1 second? Let us assume, which is not exactly correct, I'm saying it again, it's not exactly the correct thing to do, but let us just assume that the object has moved a distance of 5 meters in the first 1 second. Why? Because the velocity is 5 meters per second after 1 second. I'm assuming that in this 1 second the object has moved 5 meters, but as I'm saying, it's not totally correct to assume that. It has to be a bit less than 5 meters. But let's just assume it. So if in this 1 second it has moved 5 meters, so the velocity became 5 meters per second. After another 1 second, that is from 1 to 2 seconds, the object has to move 10 meters, because from here to here the velocity is 10 meters per second. So that means in the interval between 1 second and 2 seconds, the object moved a distance of 10 meters. That's why the velocity is 10 meters per second. And then from here to here, it's becoming 15 meters in every 1 second, right? So again, I'm repeating, this is not a very accurate representation. This is just an assumption that I'm taking to make things a bit simpler, but please keep it in mind, the distance will not be exactly 10, 15 or 5. So what we see from this diagram is that as the velocity of the object is increasing in every 1 second, first second it was moving at 5 meters per second, now it's moving at 10 meters per second, then it's moving at 15 meters per second. Every second, the object is covering more and more distance. It's moving further in each second because it's increasing its velocity. So it's like this. If I start walking at a very slow pace, in 1 second, I will cover a very small distance. But if I start moving faster, then in every 1 second, I will be covering more distance, right? So in every 1 second, since your velocity is larger, you will be covering more distance. Now, if I want to show this representation first in a speed time graph or in a velocity time graph, how does it look like? This is how the graph looks like. So the velocity time graph here is representing how much was the velocity of the object after every 1 second. So after 1 second, the first second, we saw the velocity to be 5 meters per second. After 2 seconds, it was 10. And after 3 seconds, it was 15. So if you plot these points here and draw the graph becomes a straight line through the origin. Why through the origin? Because the initial velocity was 0. If it was not 0, the graph would have had an intercept on the y-axis, because it would have started from 1, 2, 3 or something if the initial velocity was not 0. So the initial velocity was 0, then it starts to move on to 5, then 10, then 15, and becomes a straight line showing that the object's velocity is increasing by the same amount in every 1 second. So keep this thing in mind. If you see a speed time or a velocity time graph where you will find that the line is a straight line through the origin, it shows the object has a uniform or constant acceleration, which means the velocity of the object is increasing by the same amount in every 1 second. But does that mean the object is also covering the same distance in every 1 second? No, the object is covering more and more distance in every 1 second. So when you're drawing the velocity time graph, the graph is a straight line. Now the question comes, if I had drawn a distance time graph for this one, how would have the graph look like? Now that is what the students may be confused. The distance time graph and the velocity or the speed time graph. So we will draw a corresponding distance time graph for this one to see how the distance time graph would look when an object is moving with a constant acceleration. So let's go to the distance time graph now and see how does it look. Now here we go for the distance time graph. Okay. So for the same object which was moving with a constant acceleration of 5 meters per second square, the velocity is increasing by 5. After every 1 second, the velocity is increasing by 5. If we try and draw a distance time graph, how would the graph look like? Okay, so now this side, the y-axis is distance, the x-axis is always time in seconds, and we will have to draw the distance after every 1 second. Now remember, the distances that we have taken here, this 5 meter, 10 meter and 15 meter, these are all just values which are close to the actual distance, but these are not the correct values. This I have taken just for the sake of simplicity so that you can understand it better. But the actual distances will not be 5 meter. It might be 4.8 instead of 10. This might have been 8.7, 8.8. I don't know. I have to calculate. And this might not be 15, a bit less than 15. But one thing is for sure. This distance will be smaller compared to this one, and this one will be smaller compared to this one because the velocity is increasing. The object obviously will cover more distance in every 1 second. So let us just assume these are the correct distances. Just assume it and then draw the graph. So when I'm plotting the distance, after the first 1 second, let's just remove the graph first. I see that the object has moved a distance of 5 meters. Okay. Then after 2 seconds, how much distance did the object in total move? It moved a total distance of 15 meters. So after 2 seconds, if this is 10, if this is 15, so after 2 seconds I will plot a point here, right? It's 15. And after 3 seconds, it has moved a total distance of 30 meters, right? Now, after 3 seconds, if this is 15, this is 20, this is 25, this is 30. So my line should be somewhere, after 3 seconds, it's somewhere here. And my graph goes like this. So you see, the graph is not a straight line. Might not be a very accurate graph here because the line should be somewhat like this. It should be curving upwards with an increasing gradient. So when you're drawing a distance time graph for an object moving with a constant acceleration, it doesn't matter the values, you don't have to put down the values. You don't have to worry about the fact that what should be the values. If these distances are not correct, how should I calculate the distance? In your O-levels, you don't have to calculate that distance. What you have to know is how the shape of the graph would look like. The actual shape of the graph would be a bit more smoother than this one. The graph should be a line curve like this. Okay, so as you go further into time, the further you go from 0 seconds to more the time, if it's accelerating, you will see the gradient of the graph is becoming more and more steeper. Here the gradient is more steeper compared to this part. And over here it will be much less steeper. Okay, so the graph becomes more and more steeper with time if an object is moving with constant acceleration. So for constant acceleration, if you are asked to draw the velocity time graph, the graph will be a straight line through origin. Doesn't matter whatever the value is, the graph has to be a straight line through origin. And if you are asked to draw a distance time graph with constant acceleration, this is how the graph should be. The graph should become more and more steeper. Okay. So next up, we will be drawing the graph with an object moving with a constant deceleration. It's just the opposite of this one, but we'll also draw that and see how does the graph come up. So stay tuned into the channel to see more graphical representations of speed time graph in different situations. The constant acceleration, the constant deceleration, and how does the graph differ when you're drawing it for distance time and when you're drawing it for velocity time. Alright, I hope you understood the graphs properly here and you have taken the notes of it. You have drawn the graphs yourself. Hope you liked the video. Thank you.